Algebra, Mac 1105, Chapter 2, Section 1. It deals with the distance formula and the midpoint formula. So first of all, let's do a little review. This is a Cartesian coordinate system. In Chapter 1, you did one-dimensional graphing, where the negative x's were over here, positive x's over here. Well, now we put in a second axis. Now we're doing two-dimensional graphing. This is quadrant 1, quadrant 2, quadrant 3, quadrant 4, which doesn't play into much of a process in algebra, but it does in trigonometry and calculus. Here, the ordered pairs are positive, positive. Here, negative, positive. Here, negative, negative. Here, positive, negative. The ordered pairs are written as x first, y second. So anytime you're given an ordered pair, you know you have x and you know you have y. You're going to see how important ordered pairs are in algebra as we go through this class. Okay, so this is the distance formula. And the distance formula says I can find the distance between any 2 points as long as I take the square root of the second x minus the first x squared plus the second y minus the first y squared. Now, we square this in here, not because it's part of the formula, but because we're taking a square root. And you should know that we never want a negative inside a square root because it becomes imaginary. So the square there is just to make any negative difference positive, so that we'll always have a positive answer inside the square root. Here's example 1. Let's find the distance between 1, 3, and 5, 6. All right, so the first thing I did, and this is something I do because I don't want to make a mistake, is I'm writing so I understand that 1 is x1, 3 is y1, 5 is x2, 6 is y2. If I look at the formula, all I'm going to do is take these numbers and put them in their position for the variables. For instance, this 1 is going to go here, this 5 is going to go here, this 3 is going to go here, this 6 is going to go here. Then I just do the math. 5 minus 1 is 4, 4 squared is 16. 6 minus 3 is 3, 3 squared is 9, 16 and 9 are 25, square root of 25 equals 5. Done. Be careful with the distance formula because there is a minus sign here. So if my x1 or my y1 is negative, that means I'm subtracting a negative, which means I'm going to have a double negative, which makes it positive. So be careful with that. Next thing I want to go over is example 3 in your book. This is on page 153. And this is going to be kind of a problem that I'm probably going to give you on a test. It says, consider the 3 points A, B, and C. Letter A says, plot each point to form a triangle. B says, find the length of each side of the triangle. So you're using the distance formula. C says, show that the triangle is a right triangle. That we're going to use the Pythagorean theorem. And then D says, find the area of the triangle. Okay, so the first thing they did was they plotted the points. And so make sure you plot your points correctly, and then they connected the dots. Then what they're going to do, so if you look here, there's finding the distance between A and B, which is putting your distance right here. So you're using the points negative 2, 1, and 2, 3. Then you're finding the distance BC, which means you're using the points 2, 3, and 3, 1. Then you're finding the distance AC, which means you're using the points negative 2, 1, and 3, 1. All they did was set those points up in the distance formula. They got the distance between A and B is 2 square root of 5. Make sure you realize you got to simplify square roots. We simplified this by breaking 20 down into its factors of 4 times 5. Square root of 4 is 2. Comes outside. 2 square root of 5. Then we've got square root of 5 and 5. Now, the way we're going to prove it's a right triangle is we're going to use the Pythagorean theorem. Remember, the Pythagorean theorem says a squared plus b squared equals c squared, where c is the larger side. So what they've done here, here's a squared plus b squared equals c squared. So AC is the larger side. So we're going to put the 5 in there. And we get the square root of, we get 25. And then we're going to take and put for AB 2 square root of 5, which is right here. And then we're going to put for BC square root of 5. So remember, when you go 2 square root of 5 times 2 square root of 5, make sure you remember that when you take this 2 square root of 5 squared, basically what happens is when we have 2 square root of 5 squared, we really have 2 square root of 5 times 2 square root of 5. Whenever I'm multiplying radical numbers, I always multiply the outside times the outside. So 2 times 2 is 4. Multiply the inside times the inside, so that's square root of 25. Square root of 25 is 5. 4 times 5 is 20. Remember, this says 4 square root of 25, but it really says 4 times the square root of 25. Square root of 25 is 5, so 4 times 5 is 20. Coming back here, we set up the Pythagorean theorem. We can see that this is going to be 20 plus 5, which is 25, which equals 25. Because both sides of the Pythagorean theorem are equal, we have mathematically proven that it's a right triangle. Last part to this, we're going to deal with the area. Remember, the area of a triangle is 1/2 times base times height. So when we look at the triangle, we've already determined that AC was the hypotenuse. So here is our height, and here is our base. So that's the reason we used 2 square root of 5, which is our base, square root of 5, 2 square root of 5, which is our height, square root of 5, which is our base. Multiplying this times this, we get square root of 25, which is 5. 5 times 2 is 10, times 1/2 is 5 square units. We come over here, the last thing in this section deals with the midpoint formula. Midpoint formula says that the x of a midpoint is taking your two x's of two ordered pairs divided by 2. Your y of your midpoint is taking two y's of two ordered pairs divided by 2. Thus you get an ordered pair as your answer, which is the x midpoint and the y midpoint. There's an example. It says find the midpoint of -5, 5 and 3, 1. Well, again, I labeled them. There's my x1, y1. There's my x2, y2. The xm is -5 plus 3 over 2, which gives me -2 over 2, which gives me -1. So that's my ordered pair. The y midpoint gives me 5 plus 1 over 2, which gives me 6 over 2, which gives me 3. So thus my midpoint is -1, 3. Do not give me an answer of x equals or y equals. Your answer for the midpoint is always an ordered pair. Put your answer as an ordered pair. Another problem with midpoint is this one. One thing you got to realize is that in this formula, they can actually give us the midpoint and one of the endpoints and ask us to find the other endpoint. That's what this problem is. This is problem 55 on page 155. It says your midpoint is -1, 4. One of your endpoints is -3, 6. Find the other midpoint or endpoint. So you can see I labeled -1, 4 as xm, ym. -3, 6 is x1, y1. If I set it up, if I use these numbers to set up with this formula, I end up with -1 equals -3 plus x2 over 2. And 4 equals 6 plus y2 over 2. Doing the math. Multiply by 2, I get -2. Add the 3, I get x2 as 1. Here, multiplied by 2, I get 8. Subtract the 6, I get 2. I find out the other endpoint is 1, 2. So see, all you got to do is if you're labeling these, if it's a midpoint, it's xm, ym. So in the formula, it will go in place of xm, ym. If you have another endpoint, always label it as x1, y1. It really doesn't matter. And you can put it in for x1, y1, and then you just solve for x2, y2.